Hi there. In this video, I'm going to talk a little bit about the preparation process for running a neural net, particularly with this week's homework assignment. So I'm looking at the Toyota Corolla dataset here that I have on my screen. And you can see here that I've created an Excel table simply to make it easier to work with the data. One of the things that you're going to have to do is you're trying to predict price in this case. And right now, price is a numeric value. Attribute. So we need to convert that. It's called discretization when you take a numeric attribute and convert it into a categorical attribute. There's a number of different ways to do discretization. The manual ways that I'm going to talk about today mainly are equal frequency and equal width. So I played around with this to see what would work best. So I decided that I want to go with 3 categorical outcomes: low, medium, high price. And so I tried out first equal width, which is basically what I did is I went into price and I sorted it by price ascending. So you can see the range. So I have the beginning range is 4,350. The ending range is in the 30,000 range. I'll show you that in a second here. I go back over here. 32,500. And then I did a subtotal for those because I was just kind of playing around with the data. So if I look at this, I just sorted it. I first started with equal width, which means that I want the categories to be equal in their classification. So from $4,300 up to $32,000, I want to divide that evenly in thirds. I did that initially. What I found out is that my data was very skewed. I had a high number of records in the ones, the low, a fairly good significant amount in the twos and the mid-range, and then very few in threes. So I had very skewed data, which means that I'm not going to get really good results in terms of prediction when it comes to that higher level. So I decided to go with equal frequency, which that is now looking at making sure that the similar amount of records are in each category. So starting at the beginning, what I did is I created another column called price 2, and I, again, sorted it ascending, and then I'm starting with the ones. So ones is my low range. There are about 1,800 records in here, I think, or so. So I went through and I just divided that in 3. I think it was 479 per category that it ended up being. So I just went down and I'm just kind of scrolling through here to show you where I actually have a cutoff point. And let me get down, here we go. So originally what happened is my cutoff point was somewhere in the middle here in this 8,950 range. So I just fixed that. So I just decided, okay, if it's 8,950, those are going to be ones. So I went down here to 8,990. And made those twos. So that means there's slightly less twos now than there are ones, but it's still relatively equal. Same thing, I went down to where it switches over to the threes, the high category, and did the same thing. So you can see here, we have 10,950. It was somewhere in the middle of this where it switched over to the threes. I just kept it, made them twos, which means I'm adding a few more to the twos and taking a few less from the threes. But again, still fairly equal in terms of the number of records in each category. So this is going to hopefully give me better results than I were if I had used equal width. There are other ways to discretize using information gain, which is basically like using a decision tree, which decision trees use the information gain algorithm or metric to determine splitting points. But I decided to go with this method. You don't have to go with 3 categories. You could go with 2 categories. You could go with more. But I just decided to start with 3. But it's really up to you. You could even try different ones if you wanted to see how the results change. Once I have this prepped, then I'm going to go into classify, neural network, and I'm going to use automatic network. Now the variables, you'll have to use, there's some variables that I can't use in here. For instance, I can't use model because it has too many instances. You can see over here on the left, there's more than, I think it's 35 that it won't accept. So I just left model out. over here, I put the variables I could put in over here, which are numeric. Categorical variables I put over here, that's field type and color. And then my output variable is that price to that new categorical variable that I just created based on price. You can see it's already determining, it knows that there's 3 classes possible. If I go to next, you're going to need to go into training parameters and also stopping rules. So if I go into training parameters, one of the things it wants you to set for the homework is it wants the error tolerance to be 0. Originally it was at 0.1, so I would just change that over to 0. The other thing you want to do is you want to do stopping rules. So this is where the epochs are, and the epochs are really generations. So it's basically one cycle is an epoch. So 30 means we're going 30 times through this neural network from the input to the hidden layer to the output, 30 times. So you're going to start with this, and then I think the homework wants you to do it a few more times, changing the number of epochs, and that's where you would do it is in here. And then the other way to do this is you need to go into partition data and make sure you're partitioning your data into 60/40 training and validation sets. And then you're going to click finish and it's going to run. I've already run mine. And then over here, you're going to see your output. So I would play around with, try to determine number of categorical variables that you want for your output. Do you want 1 or do you want 2, 3, 4 categorical values for your output variable? And make sure that you code that appropriately before running the algorithm. Like I said, I'm not expecting you to be have this perfect analysis of all of this particular algorithm. One of the problems with this algorithm is it doesn't explain why it's decided what it's decided. So it's what we call a black box approach. We've been working primarily with white box approaches like the decision trees, which explain you get a set of rules from that decision tree. Classification rules, again, you're getting a set of rules, understanding how it's coming to its decision. And this one, you don't know how it's coming to the decision because that hidden layer is hidden, and there's a lot of permutations going on in that hidden layer in a neural net, especially as you increase the number of generations. But this should hopefully help you in getting your results for your homework this week, and also with your project as you work to get your data ready and run the neural nets and post it to the discussion board. I hope this is helpful. Again, if you have any questions, feel free to post the discussion board or email me, and I will do my best to answer any questions you may have. Have a good weekend.